So in solving rational equations, the first thing we want to do is to get rid of denominators. Once we get rid of the denominators, then it becomes something that's linear or quadratic that we have the skills to solve through. So our first step is going to be working with the denominators and using the least common denominator in a way to wipe out all of those denominators. Okay. So first thing we're going to do is determine the least common denominator of all of the rational expressions in the equation. So for this first example here, so we're looking on both sides of the equation. That helps just remember where you have your equal sign. So now we're solving equations. So now we have a bit more freedom in terms of we can kind of multiply, divide, add, subtract by anything as long as we do it to both sides of the equation. Now I'm focusing on that y minus 1, and then I can see I have another y minus 1. So that's going to be my least common denominator is y minus 1. Now our second step is to multiply both sides of the equation by that least common denominator. So I have this left-hand side of the equation, right-hand side of the equation, and we're multiplying both sides by y minus 1. Now, on the left-hand side of the equation, we have addition between two terms. So that means that y minus 1 is going to distribute. Whereas on the right-hand side of the equation, it's just multiplication. So what this will look like all written out is we'll have 2y times y minus 1. We'll have this plus 3 over y minus 1 times y minus 1, and then equals y plus 2 over y minus 1 times y minus 1. Now, for the first term, 2y times y minus 1, well, that's just multiplication, so we're just going to distribute in, so 2y times y is 2y squared. 2y times negative 1 is minus 2y. So that takes care of that first piece. Here, where I have a rational expression, we've chosen a value such that the denominator will cancel out. So we're going to cancel out those y minus 1s, and we'll just be left with 3. On the right-hand side of the equation, the y minus 1s will cancel out, and we'll just be left with y plus 2. Now, looking at this equation, it is quadratic because I can see my variable squared there. So to solve quadratic, I need to have 0 on one side of the equation. So I'm going to subtract y from both sides and subtract 2 from both sides. So on the left-hand side of the equation, we'll have 2y squared minus y plus 1. Minus 3y. Negative 2 minus 1. 3 minus 2 will be a positive 1, equals, and then we wiped out everything on the right-hand side there, so we have a 0. Then we factor. So we'll have a 2y minus 1 and y minus 1 in the factored form. You can double check this. Negative 1 times negative 1 will give us the positive 1. We'll have a negative 2 minus 1 to get the negative 3. So then we'll split it up. 2y minus 1 equals 0, 2y equals 1, y equals 1/2. And for y minus 1 equals 0, add 1 to both sides, and y equals 1. So we end up with these two solutions. But at this point, we're going to call them proposed solutions because we have to check our work. There's a possibility of plugging in a value and it doesn't work. Really, we're just avoiding the case where this denominator turns into 0. So we have this limitation on our domain of these in terms of what we can plug in. And what I can see is I cannot plug in y equals 1. That's not allowed. What we can see is y equals 1 came out as one of the solutions. So we need to toss that out. That is not a solution. Y equals positive 1/2, however, we can check that in a calculator and see that it works out. So let's see, we'll have 2 times y. so 2 times a half. I'm just going to type in 0.5. It's a little bit easier with this. Plus 3 divided by 1/2 minus 1. So that's our left-hand side of the equation. For the right-hand side of the equation, let's see, we have a fraction of 1/2 plus 2 over 1/2 minus 1. And what we can see is we would get -5 on both sides. So when we go to check, that positive 1/2 checks out. So that's going to be our solution, y equals positive 1/2. So that's our process for these. Find the least common denominator, multiply absolutely everything by that least common denominator, simplify, you'll end up with something linear or quadratic to solve. Solve as we normally would, but then you have to check your answer to see if you get any extraneous solutions. So in this case, what I can see is I need to factor that right-hand side before I find the least common denominator. So let's factor 1 over s minus 3 plus 2 over s plus 3 equals 9 over s plus 3 times s minus 3. So our least common denominator here will be an s minus 3 times s plus 3. So you can see that showing up in our denominators there, and there aren't any extra exponents, so we don't need to do anything more there. So we're going to multiply the entire left-hand side and the right-hand side of the equation by s minus 3 times s plus 3. So what that will look like is on the left-hand side it would distribute. So anywhere you have separation by addition, subtraction, it's getting multiplied by that least common denominator. So I'm going to write this out in an expanded form. So we have 1 over this s minus 3, and it's being multiplied by that s minus 3 times s plus 3. And then we have plus 2 over s plus 3, and that is being multiplied by s minus 3 times s plus 3. And then we have our equal sign, and we have the 9 over s plus 3 times s minus 3, and that's being multiplied by the s minus 3 times s plus 3. So if it's helpful to write in this form, I know it's very expanded and long, but just make sure that every single term gets multiplied. But if you like the form we did over here, where it's kind of thinking about multiplying on the outside and then distributing in, that works exactly the same way. All right, this first term, those s minus 3's will cancel out, so we'll just have 1 times s plus 3. So there we'll just have s plus 3. Over here, the s plus 3's will cancel out, so I have this 2 times s times -3, and with addition out front, we're all good to go. So we'll have a positive 2s, and then 2 times -3, which is a -6. And then equals, and over here, everything cancels out. So all we'll have left over is 9. So here we're ending up with something linear. So I'm going to combine like terms on the left-hand side. So that's going to be 3s, and then 3 minus 6 would be a -3, so equals 9. Add 3 to both sides of the equation to get 12. Divide by 3, and we have a proposed solution of 4, but we need to check that it works. Really, the big check is that it won't make any of those denominators turn to 0, but it's always a good idea to plug it in and make sure it's working. So we have 1 over 4 minus 3 plus 2 over 4 plus 3. So you can see the answer we'd get out for the left-hand side of the equation. And then 9 over, 4 squared minus 9. And we get the same exact answer out. So our proposed solution is correct. It checks out. So we have s equals 4. All right, 2 more examples here. In this case, so we have a fraction equals a fraction. Now, if you've learned cross-multiplying before, we can absolutely do that here. So cross-multiplying occurs when you have a fraction equals a fraction, and the cross-multiplication is that you have equals, and then you would multiply diagonally. So we'd have an x minus 1 times 5 equals x minus 6 times x plus 1. Now, we can see that occur from this multiplication of our least common denominator. So I want you to know you have that shortcut, but I'll show you the method we've been using, and you'll see you get to the same spot if you're comfortable with and know cross multiplication. So our least common denominator here, we're looking at that x minus 6, and we have the x minus 5. So our least common denominator is going to be the multiplication of those two pieces. So over here, we'll have an x minus 6 times x minus 5 times all of that on the left-hand side. And on the right-hand side, same idea. So when we do this, on the left-hand side, the x minus 6's will cancel out. So we'll have x minus 5 times x minus 1. And on the right-hand side, the x minus 5's would cancel out. So we would have x plus 1 times x minus 6. So we can see this is our cross multiplication. X minus 1 times x minus 5, that ends up over here. X minus 6 times x plus 1 ends up over here. So cross multiplication, or this multiplication by the LCD, does the same thing. All right, I'm gonna expand out. So over here, we'll have an x squared minus 6x plus 5 equals x squared minus 5x minus 6. If I subtract x squared from both sides, that x squared term just goes away. So it becomes something linear to solve. So I'm going to go ahead and add 6x to both sides so that I end up with x on the right-hand side of the equation. And then I can also add 6 to both sides. So then x is all alone, and we end up with 5 plus 6, which is 11. So there's our proposed solution, and we just need to check that it works. So we have a fraction of 11 minus 1 over 11 minus 6, and that's a 2. And then our other fraction is 11 plus 1 over 11 minus 5. And we get the same exact answer, so our solution checks out. All right, our last one here. So I need to factor. So we're going to have y over y minus 2 plus 1 over y plus 4 equals negative 2 over, let's see, factoring here, we'll have a positive 4 and a negative 2. That multiplies to negative 8, adds up to positive 2. So the LCD is going to be the multiplication of those two pieces. So we're going to be multiplying every single term by y plus 4 times y minus 2. Y plus 4 times y minus 2 times y plus 4 times y minus 2. All right, our first term here, the y minus 2's cancel out. So we end up with y times y plus 4. So we just distribute the y in for y squared plus 4y. Our next term, we have this plus, and the y plus 4's cancel out. So we have 1 times y minus 2. That'll just be y minus 2. And then on the right-hand side of the equation, everything cancels out. So we would just have negative 2. So I'm ending up with something quadratic here. I need to add 2 to both sides, so I have 0 on one side of the equation. We have y squared plus 5y, and then negative 2 plus 2 is 0, and that equals 0. So factor out the common factor of y, and that would leave us with y plus 5. Now we can see we'll have a y equals 0 and y plus 5 equals 0, which would solve to y equals -5. Then we just need to check our solutions. So plugging them in, just looking at the denominators, both look okay, but let's just make sure. So we're going to have 0 over 0 minus 2 plus 1 over 0 plus 4 for one side of the equation with y equals 0. And then the other side of the equation is -2 divided by, we're doing 0 squared, plus 2 times 0 minus 8. So I'm just going to throw some parentheses around that 0 there just to help me out with my next piece. Okay, so I see that that all balances out, which is awesome. Now I'm going to do the same thing, and I'm just going to edit where I had 0 before. I'm going to type in -5. So we get that out. And then over here, -5 in parentheses, -5 in parentheses, and it balances out. So in this case, we have two solutions. Both work as solutions for our equation.